All right, this is my stream of the Google Code Jam, round 2. No real preamble. We're all stuck in quarantine. Things suck. I'm definitely not at my best. We'll see how it goes. Okay, another international or incremental house of pancakes question. Okay. So this is almost within the realms of simulation working. 1,000,000,000 is enough to simulate. But I think it's probably not quite enough. So we need to compress it somehow. "20 seconds per test set, 1,000 test cases." Yeah, okay, yeah, you definitely need to speed this up a bit. But how? Let's see. So one trick you can often use is to sort of skip ahead 1,000 and see if things have meaningfully changed. In this case, it would be, have we switched stacks after doing 1,000 consecutively? If so, then you don't skip ahead 1,000. But the problem is you're going to get into this regime where left and right stacks have similar amounts. Yeah, so like say we got 2020 and we're subtracting 4. So we'll go 1620, I'll go 1615, then 10, 15, 10, 8, and so on. The gap becoming too wider. Actually, wait, does this just continue forever? Yeah, so we get into this regime where it continues always alternating left and right. So I think maybe it's going to look like, I think this is going to look like a bunch of L's and then maybe some RL, some duplication of RL for a while. Now it's possible that it flips at some point. So like there's a duplicate L and then it goes back to RL repeating. So it'll go something like L star, something like this. This isn't a very good generalization, though. I'm not even sure if this is correct. Certainly once I get to the point where they have equal stacks, then I can just accelerate to the end. This is a very mathy problem to optimize. Sorry, this doesn't continue forever. This continues until this gap gets... Wait, this gap goes up by 1 every time. Yeah, this does continue forever. As long as I can identify when we're in a situation where we're repeating, alternating, as long as I can properly identify that in code, I think I'm okay. I can just try. So this is hot.cc. Okay. Oops. I don't want to be tempted by ints. Let's just get rid of those. Okay. So if this is the case, if L minus N is less than R, then we go L minus equals N and R minus equals N plus 1. And now we have, this will just repeat forever. So cool. So this, and similarly, and now the other thing I need to get right is so I need to fill in that part, but let's see. The other part is okay. Oops. So this will be the number of reps. So start with 2. And I think I need to actually estimate this with doubles first because it might overflow. Actually, this is fine. Actually, I think this is fine even without doubles. So yeah, this is going to fit into long longs. I don't think there's a problem. All right, so that's some compression there. Just declare all this stuff first, because I'm reusing so much of it. Okay. Yeah, I'll just switch to the RL side of things. Okay. That's the output, right? Okay. So finally, just need to handle the RL case repeating forever. I don't think that check is needed, but whatever. This is kind of a mess. I'm kind of hoping that I get it right. We'll see. Okay, r is equal to 1. Oh. Okay. Is that right? So if r is 1, then that'll be the sum of n and n plus 2 and n plus 4, and so on. So the average is going to be yeah, that's right. Oh, shoot. Wait, so we have... Okay, I know that L is going to end up being greater than or equal to R, but L minus N... L minus N plus 2... Is this going to hold? Yeah, okay. That's fine. Fortunately, this test set 1 will test these anyway. Wow, I've got my order completely wrong. That would have been an annoying bug to find. Okay. There's way too much complex code here. I doubt it's going to work first time. Okay. Zero, one, one. Oops. Three, one, one. Wow. Got so much going wrong here. Okay, and then why did I do that? Oh, because I was typing something out for an example and I kept it in. Okay. None of these cases? Yeah, so I should have n minus 1, and I shouldn't be incrementing n. Okay, 1, 1, 1. L times 64, that is not right. This is p, L minus p. So many little bugs. I have no confidence in this solution. L times 8, 4, 1. So 13 is 90. Yeah, the 13th triangular number is 91, so that looks right. Okay. That looks right. And let's do a smaller case. So we have 2020 and then 1920. Gotta say, unless I'm missing something, this is a pretty difficult first problem. At least the hard case is difficult. The easy case is utterly trivial. But we're not trying to solve the easy case here. So, yeah, so that looks right. Now, what if I guess I'm not testing. I haven't tested this fallback. But that looks pretty solid. Okay. I have zero confidence in this. But let's try submitting. Got to select the language. Thank you, Google Code Jam interface. And let's give it a try. 25 minutes for the first problem. Yikes. Not a good start. Especially if it fails, which it probably will. Oh my God, it actually worked. And that gives me a lot of confidence that it works on this case too. Because this is, aside from overflow errors, I guess, okay, let me test overflow. That's actually, Yeah, that seems right to me. And that's the limit on n. That's roughly like square root of 2, isn't it? Times a billion. Wow, that works out really well. I'm a little shocked. Oh, probably because it's a square of square root of 2 or something like that. Anyway, seems to work. So the small cases test my logic, and the large cases I've tested that I don't really get any horrible overflows. And I have no ints anywhere in my code anyway. So I am reasonably confident now in the large case. Okay, let's move on. So Emacs++. Security update. Graph problem. Oh, it's a construction problem. They love these construction problems. Hold on. Isn't this redundant? Oh, exactly one of the two things. Yes. Okay. I thought they were giving us both of these pieces of information. So for computers where I know this, I don't even necessarily know where they fall relative to the computers where I know this. So for instance, the computers where I know this, so I might know that, I don't know what to, so if this is the sorted array of when everybody got their updates, I'll know the computers of the X's here. Excuse me. But then I'll also know that some computer got, actually no. All of the other ones I will know the source, the actual times for, and I can just put those into sorted order. Okay, so I do know the complete sequence of when each computer got its update. Now ties might screw this up because they've been very careful to tell us that ties can screw this up. So suppose these three are tied. Well, okay, suppose these three are tied. I mean, suppose these 4 are tied. These two values will be the same. So there's no way to distinguish the situation where these 4 are tied versus, say, these 2 are tied and these 2 are tied. But I think the ordering is still fine. So I'm still happy knowing that I know the order of the computers getting the update. It's just that, like, I will know a potential ordering. It's just that some of them may be grouped, and in some cases I will know that they're grouped. In some cases I won't. So I also know the direct connections. I actually know the network. Oh my God. And they're giving us a limited version of the problem for the visible verdict and the hard version of the problem for the hidden verdict. Let me think about this a bit more, but I might move on to another problem. Okay, this might be something like a union find type thing, where initially I start with just the source computer, then I know what the first computer to receive the update is. And I might know its time, I might not. The values all have to be at least 1, right? Each latency value must be a positive integer, no greater than 10 to the 6th. Is that 10 to the 6th going to cause a problem? It might. Oh no, okay. They're constraining this. Okay, so there's not really an upper limit on latencies. Fine. There is a lower limit of 1, which means I will probably want to use the lower limit whenever possible. So say I add this to the network, and then I go on to the next computer, and I say, oh, this one has to also receive it at time 1. So I'll connect that. I'll look at all the connections. There must be some connections to the previous computers, and I will just add something such that I will assign values to those edges such that this computer gets the update at the correct time. Okay, and then that'll be my new union, and then we'll add another server. We'll add the next server in line, and we might or might not know exactly what time it gets. If we don't know, then we'll assign it the earliest possible time it could have gotten. the update, and the distances to all of these computers that are already in the set are less than that time by definition. So then I can just assign edge values. Okay, that's actually, it's not that bad. It's actually fairly reasonable, I think. Okay. Okay, so my output is okay. So I can get away with an n squared. Okay. Runtime is not really a problem here. All right, let's start coding. So I'm going to have my first queue be order, and another queue for times. Okay. So our current set includes 0, starts with 0. Okay. You know what? I should. Not that it matters. I mean, n squared is fine, but it's just easier this way. Okay. So okay. So this is the minimum possible value. But then yeah, just in case. This is for ties. All right, so now we've got this update time for x, and okay. Not even sure I want this cur t value. I think I just want okay. So exi is equal to x and vice versa. Okay. I think I can actually generalize this. So this is going to be common code. This is just going to be much simpler. Current push back. Okay. I think we're good. So all right, let's give that a try. Okay, that does not look right. Okay, so what's going on here? Oops. Oh, fuck. I always do that. Oh my god. Wow. My environment is not, it leaves a little to be desired, I have to admit. Okay. Okay, adding 1, 1. So that looks right. Okay. Oh, yes. They love to one index in the Google Code Jam. Okay, let's try that again. Okay. Now, since there are multiple possible values for the output, I need to actually check this. So they are saying, I am saying 1, 2 has value 1, 1, 3 has value 3. So this will be order 2, 4, 3. I think that's right. Boy, this is really annoying. I have to check everything by hand. The first 3 connections need to have the same latency, while the fourth can have any valid latency. So that's no good. Shouldn't the fourth be determined? What's going on here? So the fourth connection is between got it. So when I already have 1, 2 in there, and then I add 1, 3, I'm not getting it from 2. So it's actually fine as long as I... Okay, so I just need to do a... As long as I do a max, I think this is fine. I mean, I'm guaranteed that the input works, so I think this means that I can always just do that. So this is fine. Case number 3. Any 2 valid latencies work here. One of the correct outputs. My God. Am I actually going to try checking this? So correctly set that to 10. Set that to 11. So this one needs to get it in 15. How's it getting it in 15? Through 10, 5. That works. or 11.4. That also works. Okay. This needs to get in 20. So that's 5. That's fine. That's 9. That's fine. Okay. Yeah, I think we're good. I think the differences don't matter. Okay. I was being careful, dotting my I's and checking my T's, but crossing my T's. But I think we're good. This actually isn't that hard a problem, to be honest. I think the first problem was actually harder. Yay, I have to select my language again, and let's try. Okay. It was nice of them to give the output, to give the case where you had to assign a minimum value of 1, because that might have taken me a while to find on my own. All right. Well, nobody's gotten Emacs yet? Okay. Wormhole in 1. Actually, before I get too far into this, is there any chance this is wrong? I don't think so. I think this is pretty solid. The way that I'm mixing these together, I think, is pretty solid. I'm not as confident in my large as I was in the first problem, but I'm fairly confident. I mean, it is nasty of them not to test any of this in the visible test case, but I mean, lots of other contests are nasty that way, so maybe I'm just spoiled. Okay, yeah, I've got a pretty good feeling about the large. We'll see. You can't link. Yeah, you can't link a whole to itself. That's kind of important, I think. Interesting concept. We don't have to actually construct the solution. We just have to tell them how many work. Okay, interesting concept. So obviously the starting point is we're looking for pairs of holes that are at the same slope apart from each other. Like the angle of the line connecting them is the same. We want to maximize that number. So we have 100 holes. So we can do n squared possible slopes. We can do an n cubed. Well, yeah. Okay. Actually, I'm not sure we even need to do n cubed. If I just store all the slopes, sort by slope, so that I consider all the slopes, all the pairs of slopes at the same time. So then it just becomes a problem of, okay, you've got all these pairs of points that have the same slope. How do you turn this into a solution? And this is, as long as the holes are disjoint, this isn't a problem. If you have multiple that are in the same line, all of a sudden this does become a problem, because you can do 3 in a line as long as you end there. Actually, you're never really going to want to stop in a hole unless you're completely out of holes. But you might as well always wait. Oh, wow. Okay, I just thought of an interesting situation. You could have a ladder situation. I don't know if you can see that. Oops, that's the wrong. Yeah, you probably can't see that, but you might actually end up going through the same hole multiple times in order to get a ladder of several sets of holes that are in a straight line. No, sorry, never mind. That violates the holes. Yeah, holes can only link to at most one other hole. So never mind. That does not happen. So actually, if you have a bunch of holes in a straight line, say you have 7 holes in a straight line, you can always cover 6 of those. If you start there, you can actually cover 7. But I think the starting and ending are sort of special things, because you can choose any hole to be the start and any hole to be the end. It doesn't have to be a hole that's in a straight line with something else. So you can use those as 2 free holes, obviously with the limit of the total number of holes. So yeah, really, I think what this is just asking for is pair up these holes Pair up as many of these as possible, and then the final answer is the number of holes that you've paired up plus 2. If you've got 3 in a row, it doesn't help you. Okay. So, fairly simple geometry problem once you get around the weirdness. I'll just store slopes as numerator, denominator. That way I can just sort without any math weirdness. Okay, so let's see. Should probably use this for coordinates. Okay. No two holes are the same coordinates. Okay. What the? Oh my god. There we go. I still ended up having to do some weird math stuff. To normalize the fraction, but whatever. That's fine. Better than pulling in some high-powered fraction library, which I've written. Okay. especially since I have to handle infinities as well, infinite slopes, which is always annoying. So that's the fraction. Oh, let's do just b. Doesn't matter, but okay. And ij. Okay. Okay, so this will iterate over groups, and now doesn't really matter if I do n cubed. I can be lazy. I should not use x and y in a geometry problem. Okay. This is a really ghetto union find. Okay, gx is equal to. Fortunately, I'm getting them all in the right order because it'll be sorted by the first parameter. Actually, I don't even need to do that, so I can just do. Okay. So this counts out the size of the sets. There are better ways of doing that. This is really sloppy code. Anyway. If it's 2 or 3, then I get 2 out of that. If it's 4 or 5, I get 4 out of that, etc., etc. Okay. I guess in theory this is it. Yeah. Oops. Two, three, four. Okay, so is n always at least 1? Yes, it is. Nice of them to put that special case in there. They've been really nice with the test data. So, okay, why am I getting test case 3 wrong? Wait, what? I probably should have read the samples first. So there is a weird case. It's not quite the ladder I was talking about. There is a weird case. Okay, well, I've done the meat of the problem, and I think the rest of it just boils down to handling this weird case. So just need to math out exactly how this behaves. Like, can you do a ladder type thing? So their example is showing you that there's a beginning to this rabbit hole, but I don't know how deep the rabbit hole goes. Can you do multiple ladders at the same time? If you've got multiple lines going. So yeah, as they've shown, you can cover two sets of 3 points. Having a set of 3 points means that you can begin, go back, and re-enter. So if you have two sets whose parity are off, then you can combine them this way. Okay. I am not sure whether it goes deeper than that, whether you can actually do more. But for the moment, in fact, I can try. Oh, geez, the visible is only 7. I'm going to try submitting with just this assumption. Oh, wait, not times 2. Okay, well, I'm getting the right answer. Although, honestly, it's not that impressive considering the right answer in every case except this one is just the total number of holes. I am not really stress testing my code. But you know what? Submission time matters. So I can continue to think about this, and especially if I don't get the final problem, I will just submit, see how they like it. I have to continue to think about this. Wrong answer. Okay. So there are multiple things that could be going wrong. So my sorting Suppose I've got 2 and 3 lined up. is there anything I can do? So there are two possible ways I could be wrong here. I could have a bug, especially since, I'm doing some iffy things here to sort all the slopes and stuff like that. And, I could have something wrong here with this grouping, and this doesn't really test it very well. Or my concept of exactly exactly what the math is for the optimal solution. I could just not have the optimal solution. The latter seems more likely to me right now, since I've done a pretty sloppy job of thinking about this problem so far. So I'm going to spend more time on examples and trying to break my current solution, like break my current assumptions. I guess I can also test. That's bad. That's definitely bad. No, it's fine. Oh, sorry, it's fine. Never mind. Okay. I think this is working. Okay. Well, time to think about my optimal solutions. Yeah, if my groupings are 1, 1, 2, and 3, which is sort of a maximal case when n is only up to 7. 1, 1, 2, 3. It really doesn't look like I can hit them all. Feels like the answer should be 6. So oops. Oh, that's interesting. Oops. Okay. So I wasn't even getting my purported optimal solution correct. All right, let's try this again. Probably should have just tested that right off the bat, but you know, limited time to do everything. Okay, well that actually worked. So, do I have any confidence at all that this extends to more than 7? Good question. I've got a reasonable level of confidence. The fact that you can't turn 2, 3 into a full solution, as evidenced by the fact that I passed this test case. The fact that you can't turn a group of 2 and a group of 3 plus a bunch of other crap into a full solution suggests that my approach is correct. Now the question is, can you turn a group of 4 and a group of 3 into a full solution? So if I do something like it does look like I'm always left orphaned. There's something. It really does look like I'm constrained by parity. This is not a proof. I do not have a proof of this fact, but it does look like if I have just one odd group left over, I can't get that extra hole out of it. That is my impression. Okay, let's at least look at the last problem. I mean, it's probably quite difficult. I'm actually doing pretty well. Yeah, not bad. You have to consider I'm not. I know that there are some people who are fans, but I am not in my prime. I am not. This is a casual thing for me, so um, it feels pretty good to be even approaching the top 100, assuming I get everything right. Anyway, actually, a lot of people are probably going to fail IHOP large because that IHOP large seems hard, uh, and you can't distinguish the people who have submitted just the visual, the visible test case. All right, well, we've got 55 minutes left. Take a look at this problem, which I'm probably not going to be able to solve. Okay, so up to 100,000 characters and 100,000 queries. I mean, there's an obvious way to do this with just a straight search, even a BFS, but that's not going to run in time. So nobody has solved this? Yeah, that is kind of surprising. That suggests it's very hard. They must be asking for whatever optimizations are required must be quite difficult. I mean, conceptually, the problem is simple. Just a search. So obviously, sometimes you'll want to move away from your goal. Like, you might want to move back to a parenthesis that takes you a very far distance into the future, and it might even skip over your goal. You might end up coming to your goal from the opposite side, and you might do this multiple times. Your solution could look weird, very weird. Okay, here's one thing I can say about the problem. If you have a set of parentheses that enclose both S and E, you will never move outside those parentheses. That's pretty obvious. You don't get anywhere by moving outside those. So in some sense, this is a nesting sequence of a nesting tree of I'm not sure exactly how to describe it, but like some of the queries are going to be contained just within a subtree. There will be, in fact, if you think of this as a tree, if it's a tree where how do you think of this as a tree? If you have an internal set of parentheses, then that's a child of the enclosing set of parentheses. And you pretend that the whole thing is enclosed by parentheses, I think. Then wherever S and E are, they will never go above their least common ancestor in the tree. Okay, I'm liking this tree approach. Now, when you travel to a node in the tree, there are two different values you need to maintain. One is the distance to one is the distance if you go to the left side of the tree, if you want to be on the left parenthesis, and one is the distance if you want to be on the right parenthesis. Now, does the path on the tree always look like... I don't think there's ever a need to actually go down into an unrelated node. So, in fact, the path you're taking on this tree is a shortest path between S and E. I think this is a heavy light decomposition problem, which sucks because I don't really know. I think in a previous year, I think maybe for the Facebook Hacker Cup, I tried to implement heavy light, and I don't think I succeeded. I'm bad at it. I mean, the problem here is that your tree can be extremely deep. Sure, I've simplified the problem by saying that you're doing a you're just doing a minimum traversal of the tree, keeping track of two different values depending on whether you're going on the left parenthesis or the right parenthesis of each particular node. So that's great, but that path can also be of length 10 to the 5th on that order. So that's not going to fly. You need to do heavy light decomposition so that that path has at most log n heavy edges. Well, I've got 45 minutes to try to make it work. I don't have any pre-coded anything for heavy light. I don't even really know the best data structures to work with heavy light. Decomposition. This is definitely a weakness of mine. Do I think I can actually implement heavy light in 45 minutes? I don't know. Probably the answer is no, actually. They might have limited stack as well. I'm not exactly sure what environment. I've heard that there are problems with the stack. So if I just do a tree traversal for 10 to the 5th nodes, I might blow the stack, which means I also have to implement my own traversal. This is not a problem in the ACM. Sorry, not the ACM, in the ICPC, because, or at least at the finals, they give you, unlimited stack that shares the heap. So yikes. Okay, so if you've got a line of light edges, you're keeping track of left and right distances as you go up. How do you efficiently do this. This is actually kind of an interesting problem on its own. You've got a long linear path of light edges. You are, say, at the left node of this edge, or the left bracket parenthesis of this edge. You want to get up to, say, the left parenthesis of the top of an edge that's considerably further up. What's the best way to do that? And it could involve swapping from left to right edges. There could be lots of that. You know what? I don't actually necessarily need heavy light decomposition. If I can just do path compression, that might be good enough. So I actually like that. So if I can hop up, if at each node I store how to hop from L to R or L to L, going up n steps for n, one up to 1, 2, 4, 8, etc. Then I can path compress. Okay. I like this better. I might have a chance of coding this in time. I've got 40 minutes. I am really worried about traversing the tree and blowing their stack. Obviously, in a real environment, you don't worry about the stack, but I think that they have a problem with their stack. So, damn it, it's so horrible trying to implement your own recursion. This is going to make things much uglier. Oh, there's also a bit of a problem. The root node. I cannot actually traverse the root node. The root node is going to enclose everything else, but okay, I don't think I'm going to finish in time if I have to encode my own, if I have to write my own traversal. So I'm going to say screw it and do the recursive approach. Actually, Okay, so actually, okay. Oops. Oops. Wow. Okay. So we've got 0 to 1, 1 to 2, 1 to 3, 3 to 4, 4 to 5, 5 to 6. Okay, that seems reasonable. So correctly parsing the input, I guess. Whoa. Oh, I'm not clearing. Oops. Okay, so this is reasonable. So parent is Okay, so I can follow things backwards. Now, that's so weird that they give us individual. Oh well. Okay. Should probably just have a node structure, but whatever. I'm sort of rushing through this. Okay, so NL. Yeah, this is getting too unwieldy. Minutes. Still a fair amount of time, even though this is really getting ugly. This is horrible. Okay. Ugh, this is horrible. I am sorry for how horrible this code is. Okay. Because, I mean, the problem is that you might want to just traverse the whole thing, or you might want to skip from end to end. Ugh, it's so bad. And there's more. I mean, I have to do these values. Thankfully, I'm only going one direction. I'm only going from child to parent. Okay. 20 minutes left. I don't think this is going to happen, but I'll keep at it. Because I still need to do the path compression, which is not going to be trivial in any way. Okay. I mean, let's just get it working without path compression first. So this variable is only going to be if I go directly to the left and then up. I'm not going to include other situations. Those will be handled by the actual logic. So no, unfortunately, I don't know the right distance yet. How do I get the right distance? Is it just subtracting out? Yeah, maybe. So actually, I'm only maintaining this, which is a bit simpler. hack, but whatever. Okay, in theory, this should be right. So now, "12 minutes left." This would be such a miracle if I end up getting this. I don't have time to be so neat. Ugh. Damn it. Okay, let's do heights. Okay. No, this is wrong. Okay. Okay. Yeah, there's no way. But I'm close. I think I'm close. Aside from bugs, all I have to do is do a skip list type thing where for random nodes, I do a random jump up, and I store the value of that random jump up, and then here I can just test whether following the random jump takes me too high, and if it does, then I don't take it. But that compresses it so that it's all so that you end up taking roughly log n steps. But there's no way I can get that in 6 minutes, unfortunately. But I've got close to the right idea, I feel. Okay, let's just keep coding until the time's done, because I'm a sucker for punishment. Okay. Oops. Okay. Well, done coding the simple version. Of course, it's not going to work. Good God. Oops. going on here? yn2 was not declared in this scope. Yes, it was right here. Min catching my type errors. Nope. I kind of want to just submit the slow version. 0, -1, 0. Okay. What? It's getting that far. Oh, I'm missing the case of siblings. Just jumping directly from sibling to sibling. Yeah. So I left that out of my coding anyway. So whatever, we're done. And so, yeah, the idea I had in mind for making it faster was to add skip list type jumps that are of random length. Basically, at each node, you do sort of a random number. You take a random number and then say try jumping that random number up. I think the random number can be between 0 and 2 or something like that, 0 and 1. You store not only the parent, but also 2 up. Sorry, you pick a random number and then you do that many powers of 2 up. So either you store the parent or you store the parent's parent or the parent 4 times up and so on. And you do that by following compressed paths up. And I think that's efficient enough. I mean, there are clever ways of doing it, but that was my idea. That was going to be fairly low effort to do a path compression. You throw in the randomness, and then you don't have to think about it too hard. Or you can do something like for height's 0, you don't go up. For height 1, you go up 1. For height 2, you go up 2. For height 3, you go up 1. For height 4, you go up 4, and so on like that. You can do that too. Actually, that might work better than randomness. Yeah, but another thing I was leaving out of my code, unfortunately, was I was going. This all works up until you get to the same level, but once you're at that level, you don't have to go to the parent necessarily. You can hop from sibling to sibling, which I am not including in my current calculations. Um, you'd have to do something like you'd have to subtract out L to PL from one node from another. You'd have to do more horribleness, even on top of all of this horribleness, to get that. So anyway, that's how I intended to solve it. But hard problem, very hard problem. Kind of wish I had a heavy light decomposition in the bag. So how did I do? I failed security update. Okay. I mean, I still advanced, but I didn't do very well. Only one person solved both cases. Yeah, that was a hard problem. I mean, I feel given another half hour, I would have had a decent chance of solving both cases, but it was not to be. It's so annoying going from costs of one. Like, a lot of my logic is just to handle costs of more than one. Like, I don't have to do some of this crap. If P of S is 1, I don't have to do this, for instance. I don't have to sum up all of this crap. But you still have to do the path compression, or you still have to somehow compress it so that you do it efficiently. And so not very many people manage to do that. It was a very hard problem. Yeah, grats to this guy. Bank. I actually don't know who Bank is. Ben Q. I know several of these people, of course. A lot of familiar faces up in this set. I did not do well. I wonder what I failed on security update. Looks like my wormhole in one, my logic that I didn't prove was correct. So, yay. Anyway, I advanced. I did pretty poorly, but I advanced. That's what matters. The trip to Munich, there is no trip to Munich. It's been canceled because of the coronavirus. So there's not actually that much at stake anyway. The prize normally that I shoot for is a trip, a free trip to somewhere, but it's not happening this year. So anyway, this was round 2. I am definitely not at my best these days, but I will stream round 3, regardless of how poorly I do. I will throw the stream up. I don't know. I'm just not that good these days, so I don't know how educational it is, but there do seem to be something of a paucity of coders who are throwing their stuff up, their live streams up on YouTube, especially with commentary, I suppose. The commentary is unusual because it does hurt your performance a little. I probably will not commentate quite as seriously for round 3, because that's the serious one where I really have to focus in order to even have a chance. But I will put up my video regardless of how poorly I do. So I'll see you all at round 3.